Hi folks, let's solve LeetCode closest subsequent sum. So it's actually a pretty hard problem. If you haven't read this problem, you can take some time to read it. So the problem is giving us an integer array called nums and also giving us an integer called go. So we need to find a combination in nums to make their sum is closest to go. We can choose all the numbers, or we can we don't need to choose any numbers. We can choose empty nums. For example, in example 1, we can choose all the numbers. So the sum is 6, go is 6. So the difference is 0. In example 2, I can choose 7, -9, and -2. So the sum is -4, go is -5. The difference is 1. In the third example, I can choose empty array. I don't choose any number, so sum is 0. Go is -7. So the difference is 7. The constraint is the nums can be, like the length can be 40. We know we can choose this num, or we can discard it. So if we use brute force, it will be 2 to the 40. It must be TLE. How can we reduce this time complexity? Let's talk about a concept called meet in the middle. Assuming it's linking, we have first level connections, we have second level connections, we have third level connections. So can I know Obama through 6 people? Assume on average, everyone knows 100 people. The first naive solution is I can get all my first, second, third, fourth, fifth, sixth connections, and I can check if Obama is in it. For this approach, I need 100 to 6 time and space. For second approach, I can get all my first, second, and third level connections as A. I can get all of Obama's first, second, third connections as B. Then I can just check if Obama is in A, or if I'm in B, or if people in A know someone in B. So we can reduce time and space to about 100 to 3. So how can we apply the meet in the middle tricks to these LeetCode problems? Let's say we have num and we have go. First, we divide nums into 2 halves. Then we can generate the combination sum. We generate A from first half, we generate B from second half. Don't forget to put 0 since we can choose 0 num. The generation of this combination sum is pretty simple. So for each element, we can iterate all the previous sum. For all the previous sum, I can apply this new number. So we can push back previous sums plus the current number. Now we reduce the initial problem to a sub-problem. The sub-problem is given two integer array A and B. We can choose a number in A and we can choose a number in B, and we need to find such pair to make their sum closest to go. So we can use double for loop. We can for loop A, then we can for loop B. Then we can check A plus B, and we can update answer every time. But we know it's double for loop. It's not fast, and it will be TLE actually. So we need to improve it a little bit. We can use binary search. For each A, we can find an ideal element in B. The prerequisite of binary search is this container is sorted. So we can sort B first. Then we can find an ideal B for each element in A. We can use binary search. We know if A plus B is go, then B is go minus A. So we need to run binary search to find go minus A. In C++, we can use low bound. Low bound will return number, actually return an iterator that point to the element that just greater or equal than the number we want to find. We know this number is just greater or equal to the ideal number, and the element before the iterator is just less than the ideal number. So we need to check both numbers. At first, A is 0. We run low bound on -5. It returns pointer to -2. So current answer is -5 minus -2 minus 0, then take absolute value is 7. Next A is 7. We run loop bound on -12. It also returns pointer to -2. So the answer is still 7. Next A is -9. And we run loop bound on 4. It returns to 13. Then we check -5 minus 13 minus -9 is too large. -5 minus 0 minus -9, it's 4. So answer becomes 4. At last, A is -2. We run loop bound on -3. It returns pointer to -2. So answer will become -5 minus -2 minus -2, it becomes 1. So 1 is our answer for this example. So what's time complexity? We know in combination sum generation, for A and B, we have 2 to the n divided by 2 number. We have so much numbers in A and in B. Then we have binary search. We iterate every element in A, and we run binary search. So it's L log L. L is this number. So the time complexity is this number, and we know it's log. We can move this out of the log. It becomes this formula. So the final time complexity is O and multiply this number. It's pretty large, like exponential. This is implementation. I will put a link in my YouTube link. And we can say I first divide it into 2 halves, then we generate the combination sum and we sort B. Then we just iterate every element in A and we run binary search on B. So it's actually a pretty hard problem. There's so many tricks here. You need to use binary search, you need to apply the meet in the middle trick. Yeah, thanks. So this is all the element today, all the content today.